Ever looked at a calendar and just kind of wondered if certain dates have, I don't know, a hidden magic to them? Well, today, we're literally tracing the foundations of our entire digital world back to one single, golden date in math history, June 5th. It sounds almost too incredible to be true, but the tech we rely on every single day was actually built by brilliant minds who all share this exact, astonishing connection on the calendar. Let's get right into it.
So just think about this for a second. How exactly does a search engine like Google instantly know exactly what you're looking for out of literally billions of possibilities? Or, hey, when you grab your smartphone, how does that little weather widget predict if it's going to pour rain this afternoon with such crazy accuracy? It feels like everyday magic, right? But the answers to these modern mysteries are deeply rooted in math history. And as you'll see, they all astonishingly trace right back to June 5th.
Here is our timeline of June 5th milestones. In 1814, Pierre Wantzel is born. In 1904, George McVittie is born. In 1926, Claude Berge is born. And in 2009, Rajeev Motwani passes away. Okay, let's start with our very first mystery. The World Wide Web is just this unimaginably massive ocean of information. We're talking billions and billions of websites, articles, images, the whole shebang. Yet you type a simple phrase into a search bar, and boom, the exact page you need pops up in a fraction of a second. How is it even possible to sort through all that chaos and find perfect order?
Well, the answer brings us to Rajeev Motwani. He was an incredibly visionary, Indian-born American computer scientist who tragically passed away on June 5, 2009. He's widely known as the brain behind Google. As a kid in India, he was a massive reader, devouring novels, science books, you name it. He eventually grew up to become a legendary professor at Stanford University. And he is, quite literally, one of the foundational brains behind the search engine we all use every single day.
So at Stanford, Motwani was leading this research group called Midas. And there, two young students, you might have heard of them, Larry Page and Sergey Brin, were kicking around this idea of mapping the web. Motwani realized that to actually tame the World Wide Web, you had to use randomized algorithms. Basically, mathematical models that inject a calculated little dose of chance to sort through mountains of data efficiently. He mentored the founders of Google, and together they co-authored the famous PageRank algorithm, which brought order to the web.
So, what does this all mean for us? Every time you Google a question, you are using Motwani's math. It wasn't just basic programming. It was this deep, theoretical computer science that made it possible to rank web pages by their importance. He literally took abstract math concepts and turned them into the most powerful information sorting tool in human history. How cool is that?
All right, let's switch gears. Imagine it's the 1940s. The world is at war. Knowing whether the skies will be clear or stormy isn't just about, planning a picnic. It's quite literally a matter of life and death for fighter pilots and bombers. But here's the catch. Weather data is heavily encrypted by the enemy. How on earth do you break secret codes to forecast the weather and basically turn the tide of World War II? To figure this out, we have to look to George McVittie, the weather codebreaker, who was born on, you guessed it, June 5, 1904. McVittie actually had this incredibly dramatic early life. He survived the burning of Smyrna in Turkey as a youth, lost literally everything, and then managed to scrape together enough money to study math at Edinburgh and Cambridge. He was a true pioneer in relativity and cosmological theory. But when World War II broke out, his genius was needed for something way more urgent. He headed up the highly secretive Bletchley Park Met Group during the war. His team intercepted and decoded enemy weather data for the Allied air forces. Using insanely complex math and code breaking, he provided the vital observational data needed for accurate forecasting.
And this leads us to a pretty massive realization. The math that predicted WWII weather is the exact same logic in your phone's weather app today. The modeling techniques he pioneered under extreme wartime pressure laid the absolute groundwork for modern predictive meteorology. So when your phone tells you it's going to rain at 3 p.m., you're directly benefiting from a June 5 mathematician who broke weather codes to help win a war.
Okay, let's fast forward to right now, to something you probably used just a couple of minutes ago, social media. Have you ever wondered how Instagram or Facebook perfectly recommends friends to you? How do they just know that if person A knows person B, and person B knows person C, then A and C should probably connect? How do you map an invisible network of human relationships?
Well, this brings us to Claude Berge, the sculptor of the network world, born in Paris on June 5, 1926. Now, Berge wasn't just a math guy. He was an actual sculptor, a collector of exotic art, a huge literature fan. But his real calling, that was the abstract math of connection.
He's basically a pioneer of modern graph theory and combinatorics. Berge mapped out the relationships between isolated points, cities, and people. He noted that we're basically drawing a graph anytime we connect points with an arrow to symbolize a relationship. He even formulated the famous strong perfect graph conjecture, which took mathematicians like 4 decades to prove. Oh, and fun fact, he once wrote a math murder mystery where Sherlock Holmes uses a theorem in graph theory to catch the killer.
At the end of the day, Berge gave us the mathematical language to describe digital connections. Because every social network you use is just a giant graph theory puzzle. The algorithms suggesting your friends, mapping your followers, even finding the quickest route on your GPS, they are literally all solving his equations. He took this super niche area of math and made it the architectural blueprint of our connected world.
So we've seen math build all these amazing things, but what about the limits of math? Since ancient Greece, humans have tried to solve these crazy geometric puzzles using just a ruler and a compass, like trying to draw a cube with exactly twice the volume of another cube. Centuries went by, and the brightest minds just kept failing. So how do we mathematically prove that a puzzle is completely impossible to solve, so people can finally stop trying?
That impossibility brings us to our final visionary, Pierre Wantzel, the solver of impossible puzzles, born in France on June 5, 1814. Wantzel was an absolute prodigy. I mean, by age 9, he was solving complex surveying problems his own teachers couldn't even crack. By 15, he was publishing square root proofs. He was just operating on another level.
So what did he do? He analyzed these ancient geometric problems like doubling a cube, and at just 23 years old, he didn't solve them, he proved they were impossible using just a ruler and compass. He settled these age-old mathematical debates by showing the math simply didn't allow for it. Tragically, he lived a feverish life, working himself to the bone, abusing coffee, pulling all-nighters, and died very young from overwork. But his legacy? Completely permanent.
Wantzel's short, brilliant life really proves that sometimes the greatest math achievement is proving what cannot be done. He basically saved future generations of mathematicians from wasting their lives in unsolvable puzzles by setting the absolute boundaries of geometry. Understanding the limits of a system is just as crucial to science as pushing its boundaries.
A world made of math. Let's step back and look at the big picture here. From the exactness of a Google search with Motwani to the predictive power of weather forecasts with McVittie, the sprawling digital webs of our social media mapped by Berge, and the profound limits of logic proved by Wantzel. 4 incredible journeys, all tied to June 5th. It shows us that the technology we take for granted isn't just magic. It's a world built layer by layer upon a foundation of rich mathematical history.
And that brings us to the end of today's explainer. If you found these mathematical mysteries as mind-blowing as I do, please hit that like button and subscribe to Maths Made Easy Suresh for more awesome connections. But before you go, I want to leave you with this. If the algorithms running our modern lives were mapped out by mathematicians born over a century ago, what impossible math is being written right now that will completely dictate the world 100 years from today? Keep questioning, keep